Good morning, boys and girls, and welcome back to another day with Mr. Mortar here. Today we're going to talk about performing operations with complex numbers, day one, and we'll talk and get further in these tomorrow with day two. But complex numbers is just an addition to our number system, which we'll go over here in a second. But it's when we start including imaginary numbers. So first we got to talk about this imaginary unit I. You'll see on a complex number. Complex numbers are written in the form of a plus bi. Okay, complex numbers are written in the form of a plus bi. That I is our imaginary unit. And what we define that imaginary unit to be is the square root of -1. And then we also define I squared to equal -1. So those are in the definition of what I is. When we start playing around that, and those are some things we're going to want to keep in mind. Okay. Just a little bit more here real fast on complex numbers. This is our number system that we use in math. You should be halfway familiar with it. So just kind of a quick little review here. Natural numbers are numbers that you first learn when you start counting, like 1, 2, 3, 4, 5, 6, when you're like 3, 4 years old. As you get a little bit older, you start understanding the concept of having nothing. And so that's where whole numbers come in, because now you include 0 to our natural numbers. And then you get a little bit older, and we started learning about that you could actually be in debt stuff. You can not have stuff. You owe people things. And so that's where then we needed integers to start covering that idea. So that's when we included our negatives, like -1, -2, -3, and so on. And as we get more complex, more advanced, I guess, mathematically speaking, then you can start dealing with parts of stuff like fractions and decimals. And so those numbers are called rationals. And again, that includes everything that's on the inside of here. And then beyond that is our irrational numbers. Numbers like pi, I'm sure you're aware of. Square roots are irrational. And if you put all those together, that is our real number system. So when we're solving equations with all real numbers, we're saying any of these numbers would work in those equations. Okay, these are our real numbers. Now, getting even more advanced is off to the side. What we're going to include today is imaginary numbers. And those are going to be things in this a plus bi form where the I part is not 0. Okay? We actually have an I in our answer. And if you take the imaginaries and the reals and you put them all together, that makes our complex number system. Okay? So that's kind of how we organize numbers in math. A little number theory for you there. All right? So again, review. Complex numbers are numbers in the form of a plus bi. I is defined as the square root of -1, and I squared is -1. And then so an imaginary number, again, is a complex number where b does not equal 0. All right? But really what these are going to allow us to do, this complex numbers, is the way we use this I is it allows us to take the square root of negative numbers. Before, if I want to take the square root of -144, like here below, we had issues because we said, hey, we can't take the square root of negative. Nothing times itself equals a negative number. So what we do now to kind of help us skirt around that issue is we're going to split this up. And we're going to say, hey, this is the square root of, oops, got to get my pen. This is the square root of 144 times the square root of -1. Okay? Because now I can take the square root of 144. Square root of 144 is 12. And now by definition, the square root of -1 is I. And so we can now take the square root of -144. We're going to say that that is 12i. So really not that bad. It's just whenever you say negative on the inside, know you're going to have to pull that out as an I. The same thing now on the next one. Number 2, if I want to simplify the square root of -8, right? I want to break this down like we've done before with my perfect squares. The square root of 4 times the square root of 2. That's how I'd simplify that. But this negative is going to cause us issues, so we're going to break that out separately. And I'd pull out that, again, that's square root of -1. Okay? 4 times -1 times 2 is still going to give me -8. It's just I'm breaking up the separate pieces. Square root of 4 is 2. Square root of -1 is defined as I. And the 2 stays on the inside. So 2i root 2. I wrote them in that order because this is the order we are going to write our numbers in. The perfect square always goes in the very front. That is your coefficient. Then I would say the square root of -1 goes next, because when you write it, you're always going to say like 2i, and the square root is always the last thing. You want it in that order. That's the way we generally write things. Okay. If you start moving the order around, you're going to get confused and answers aren't going to match. So make sure you write it in that order, please. All right. Last one here, the cube root of negative 64. If you remember from our day 1 material, we said that, hey, I can't take the square root of a negative number, but we can take the cube root. I can say, hey, there is something times something times something that's going to equal negative 64. That's a number on your list. This is one that we should recognize. And so hopefully like, yeah, Mr. Mortara, that is negative 4. Okay? And so true statement, when you deal with cube roots, you will never ever get an I. I's only come with square roots because the I is defined as the square root of negative 1, not a cube root. All right, let's move on to some more examples here. Okay, so we're going to get more into this down the road later on when we start dealing with quadratic equations. But quick little more solving equations, and now equations that have an x squared in them. If I want to solve this equation, x squared equals negative 81. Just like before when we were solving simple linear equations, and we had to do the opposite to get rid of stuff. I had to divide to get rid of multiplying. I had to subtract to get rid of adding. Okay? Same idea here. We're still going to use these opposites, these inverses. And so if x squared equals negative 81, and I want to get rid of that squared, well, the opposite or the inverse of a squared is a square root. So I'm just going to go ahead and I'm going to square root both sides. Okay? A couple things when you're solving an equation with square roots. If you root both sides, like when I teach this in class, I always made kids, whenever I said root, everybody in class had to yell plus or minus. Okay? If you want to do that at home, that'd be awesome. But when I root both sides, plus or minus, you need a plus or minus sign in front of your answer. Okay? Every time. That's because, I'm going to come back to this problem in a second here, but that's because if I have like x squared equals 9, and I root both sides, x could be 3, because 3 squared is 9, but x could also be, so that's the plus part, but x could also be negative 3, because negative 3 squared also gives me 9. So to account for both of those solutions, I need to put a plus or minus every time I root both sides. Okay? So anytime you root, make sure you put your plus or minus. So that's my first step. I root both sides, I put my plus or minus. Now I've got to deal with simplifying my square root. And yet I would take my time and do these things separately. When we try to combine steps and do too many things all at the same time, that's when we forget to do things and when we mess up some of our steps if we try to do all in our head. So very first step, get down your plus or minus. Now for that square root of negative 81, well, I know the square root of 81 is 9. And now again, whenever I see a negative on a square root, I know I have to pull out a I. So this would just be x equals plus or minus 9i. All right? Same thing on number 5 now. I want to go and get x by itself. So first step to isolate the variable, like we did before, I'd want a minus 15 from both sides. So we get x squared equals negative 10. And then now I'm going to root both sides. That's right, boys and girls, plus or minus the square root of negative 10. And now I can focus on taking the square root of negative 10. Well, I've got to simplify this square root. That's not a perfect square. So can I divide it by 4? No. Can I divide it by 9? No. So I can't really pull anything out. The only thing I can and have to pull out, if you have a negative on the inside, you have to pull out this negative as an I. So this would become x equals plus or minus I root 10. Okay? And that would look exactly like that. And that's how we would solve that equation. All right, number 6. One last time here. Same idea. But hopefully we're kind of getting the hang of this now. I want to get x by itself, so I'm going to subtract 11 from both sides. If I do that, I get 2x squared equals negative 48. Then I'm going to go ahead and divide everything by 2. And I get x squared equals negative 24. Then I need to root both sides. That's right. Plus or minus. And now I have to simplify my radical. Always, always, always. So I can pull out 24 divided by 4. I can pull out a 4. Can't do a 9 or a 16. Then we're too big, so I can pull out a 4. So plus or minus 4 root 4 times square root of negative 1 times the square root of 6, or x equals plus or minus 2i root 6 would be our answer. All right? All right, a couple more real easy ones. Today's not too bad of a day, I don't think. So hopefully we'll enjoy this one and breeze through it. Now, sums and differences are add and subtract complex numbers. When you add and subtract complex numbers, you're going to add or subtract their real parts and their imaginary parts. And I say this is not bad because this is exactly like we would do with like terms anyway. Like if these were x's instead of i's, I'm going to treat it the exact same way. All right? So if I want to do 7 plus 2i plus 2 plus 8i, I first would distribute the ones in front to get rid of my parentheses. 7 plus 2i plus 2 plus 8i. In this case, it doesn't change anything. And then I'm just going to combine my like terms. I'm going to add the real parts, the 7 and the 2. 7 plus 2 is 9. And then I'm going to add the imaginary parts, the 2i plus 8i. 2i plus 8i is 10i. And that's how we deal with complex numbers. So again, it's a lot like things we've done before in the past. Nothing really new. Same idea on this next one here. I'm going to go ahead and get rid of my parentheses. In this case, I do have to just be a little bit careful because there is a negative in front of this back set I got to watch out for. So this becomes 4 plus 3i minus 2. Negative 1 times negative 8 is plus 8i. And now I'm going to put together my real parts. 4 minus 2 is 2. And my imaginary parts, 3 plus 8 is 11i. And that's it, boys and girls. All right, thank you very much, and I will see you again tomorrow.